Nope.
There, now you can hear me. Always with the stupid mic. And the mute. Anyway. So last time we were comparing real-life code to Visi here, and I do think I'm going to propose it to the guy who has Simple Rockets too, to actually produce something that would take Visi code and output C code, because I think that'd be pretty cool to be able to program in that drag and drop environment, but actually produce something I can actually use on a hardware target. And I don't think there'd be a problem with that. It'd probably be easier for him than me to start over, but it's all XML, so I don't think I'd have a problem just reading in the files off of the game location and doing the conversion myself. And maybe also do a version for C#, which is apparently the language of choice now for all of these game systems. C was really good for all this low-level embedded stuff. C++ for desktop widgets and GUIs and things like that. And statistical modeling of traffic and all that kind of stuff. Object-oriented is great for all that. But it's bloaty. It takes a lot of memory relative to the C stuff. We still deal with systems that have really small amounts of memory, relatively speaking. Like single-digit megabytes of RAM to deal with. Unlike all these desktops with freaking gigabytes of RAM. So, today we're going to sort of delve into the other side. Last time we had the code for the rocket, well, time before last. We had all this nice code for the rocket. We did a nice fly around, did an orbit around Drew or Dro or Dra. I don't know. DROO is the planet name, so go figure.
It's probably Drew.
Drew, yeah, sounds about right.
Choose.
And then we tried the same rocket from Earth, which of course didn't go well. And we're still on Earth, or the simulated Earth. But all of this is about the abort situations, so we're probably not going to make it very far up into space. So we have to have now software that can generically take off, and also, or at least in a way that we can easily reparameterize, like when to start our turn and that kind of thing. But otherwise, it already has the code involved to execute each of the stages of the turn and the orbit and the circulation and so on. So now we got to deal with the unusual situations along the way and still manage to make it all nice and safe. So the first thing we did in that was actually done last time, where we put the program for the parachute in the parachute itself, so that it was independent of the code running in the capsule. Of course, if we lose the capsule, what's the point to, right? But in any case, so we want to sort of distribute the code. So distribute the load and distribute the redundancy. So let's go right in there. So this is our program. Let's see if we can get some
kind of small
system music.
But you can see it all.
Well, that's the whole thing.
I can see it with my glasses on.
We just squinted. Oh, we can zoom in a bit.
No, I can see it.
So we have our countdown and ascent and the slow pitch over. So we functionalized a couple of things, like the slow pitch over. Then we functionalized each stage and then created this sort of master program. That's what actually decides what happens during a given launch, right?
Right.
So a couple of things I've learned in the time I've spent experimenting with this is, one thing, you want to name your parts so that you can refer to them in the scripts. So by default,
keeps telling you that.
Well, by default, they're all like, this is just interstage. Well, they're all interstages. And actually, this is the Capsule Interstage, for example. Right? And these are probably going to be somewhat arbitrary names. The Capsule Interstage. We abbreviate a lot. So that, it doesn't take as much typing.
Hi, everyone.
Capsule Interstage. Better? So we want the Capsule Interstage. We also want to be able to refer to our engine. Not that one. That one or that one. The Pixie engine.
Don't see.
So our Pixie engine, which is the little guy in the middle there, the third stage, I guess. Booster, core, and I guess
That's
second
still
stage.
Not enough to get anywhere, is it?
Not really. Not off the planet Earth. But that's not what we're looking at the moment. So let's go ahead and... Oops. Pixie engine. Let's name this... We'll just call it upper stage. Engine. And we always leave off the last few letters because we get lazy. It's just encoding, you get tired of typing the same stuff. Really long keywords and such. We actually won't type it very often, but we know it's an engine. So that's just a little abbreviation to separate it from the upper... We could also say upper stage IS. I don't know why I said capsule IS. Well, it's not the capsule IS. This would be the upper stage interstage. Upper stage interstage? What they call decouplers in Kerbal. They call interstages here. So let's start dealing with what happens when things don't go as according to plan. We're going to launch. We've got the same program as before, but we're going to introduce a failure. The thing that what's his name was so distraught about us doing in Kerbal, introducing failures in a game about failure. We're just going to throttle up. We're going for launch, right? There's the problem.
What's the problem?
The problem is your upper stage went and got destroyed. Now you got these boosters just flying off into space.
What is that?
Well, but see, now our program still thinks I'm trying to pitch over and do various stuff. Like, I'm going to get anywhere now, right?
Oh.
In fact, I'm actually going downward. Nothing in my program except for my parachute is operating right now. It is operating, it's just waiting for something that's never going to happen. It's like it's trying to get to an apoapsis and that kind of thing. In fact, it looks like the parachute isn't making it either.
Oh.
Nope. Oh, look, we bounced. How convenient.
Oh, no. Oh.
Whee! Alright, I'm just going to save us with the parachute there.
Why do you like to do this?
Well, this is failures. You know, your center core or engine might explode on takeoff. It just did. Now, does your software handle such a thing? Clearly not. So let us correct our software, shall we? Yes, yes, come here. Every time lately. Come on. Come on. Come on. There she is, folks.
Oh.
The lap dog. Alright, you just sit right there while I talk about rockets and stuff.
Okay.
Okay. Alright. So, we need code to handle such an event, right? So we're going to have sort of a special event case, another custom instruction called Abort, right? Which will get called in case we need to abort. Which, actually, in reality, could be caused by a critical event in the aircraft, or actually being told to abort from the ground. Plus, in this game, it looks like every time we've taken off, the booster rockets just fell back to Earth and smacked into somebody's house, right? So we should maybe have the boosters destroy themselves on the way down safely after they've departed. And to do that, they'll need their own computer chip. So, first off, let's just do that. Let's handle the boosters first. So we're gonna go into the booster. Or go near the booster, I should say, and give it a computer chip. Well, sometimes it's easier to do it this way, where you disassemble the nose cone first. So now our boosters will have their own little control chips, which is what real hardware would have, right? Especially if you want to eventually make these boosters land themselves. It's going to have its own computer. We'll get into some interesting little side effects that don't appear to be totally accurate. But anyway, it's good for now. So now these individual parts are in the list, the individual chips. The command chip and command chip here. So that in reality is the booster command processing unit. And luckily, since they're tied together through symmetry, what I program in one chip will be programmed into the other chip.
Yes.
Which is convenient and not convenient because each booster has to be dealt with separately.
CPU. Come on, my bro, slow it down. Come on, be good.
Alright, so now we have down here under the Tinker panel for the CPU, we'll add its flight program. Alright?
Yeah.
So, completely independent of the previous one, runs on its own thread. So, we're essentially going to do the same kind of thing we did with the parachute, which is we wait until we have a vertical speed of some significance, or maybe wait until we reach a particular altitude, because you wouldn't want to necessarily blow up your boosters if you were close to the ground. You might rather just have them smack into the ground. Maybe, maybe not. I don't know. This is kind of arbitrary. But in this case, we're going to wait until said spacecraft's altitude is, let's see, we're going to have an altitude greater than 1,000 meters, which is 1 kilometer. So if we're above that, now we want to wait until we're falling, right? And luckily that's essentially the same command, except instead of the greater than, it's a less than. So now we wait, not altitude either, we don't need altitude, toss that guy. What we need is velocity. So now we're going to wait until our velocity, our speed, vertical speed, is less than 0. Basically, we're falling away, we're falling at all. Right? Maybe we'll give this 10 meters a second vertical speed falling so that it's at least somewhat away from us, right? We don't want it to self-destruct right next to us. Which, by the way, let's save to craft, and I might need to name the booster here. They call it fuel tank. It is really booster on the right. And I don't know why the symmetry doesn't apply to the names, but anyway, booster left. That'll be useful for later. So back to the part list. Our see, same thing here. Even though I guess I'm not going to do anything to the booster CPU, I'm just using it, so I guess it doesn't matter that they have different names on each symmetric booster. But in the actual command, in the program, I have to talk to each booster separately. So it's the same program on both boosters, but only one of these commands is going to work because only one of the boosters is connected to each command chip.
Huh?
So I'm going to tell it to set part, and I need a part ID, and then this is where the naming comes into play. Is rather than have a part ID and having to memorize those, and I think maybe they change if you edit your rocket a whole mess. So it's easier to come in here and say set part ID of part name, booster
That
left.
seems easy.
Right?
Right?
And we're going to make the booster left explode to the maximum explosion. So this basically says wait until you're above a kilometer, then wait until you're falling.
Right.
And if you detect that situation, blow yourself up. And then blow up your neighbor, just in case this code is running on the other booster.
So, right?
So that's a pretty straightforward program, right?
Well, that's funny.
So,
That is so straightforward, even I get it.
Yeah. So the idea is that, we don't have to deal with, our main program doesn't have to deal with this part of the booster logic. And plus, our main program won't be able to control the boosters once they're detached. That's the other reason why we had to put a chip on each booster, which is also the other why we have actual hardware on every booster.
Right.
And every stage has its own computer. Computers are cheap, first off, by and large. So we'll save that to the craft. Now we'll go take off, and once the boosters detach in the natural sequence of things here, they should destroy themselves once they're reasonably far away from the rest of us. Hopefully it takes, 10 meters a second is fast enough for them to fall in a reasonable distance. I guess we'll see. Actually, this is roughly the best view, I think, for the booster stages.
I have to cough.
Alright, we're back. More pitching.
I thought you were not going to pitch.
Well, we haven't changed the flight program yet. This is dealing with the unusual attitudes. We're leaving the main flight program as much alone as possible. And we're adding in the abort sequences. So first we deal with cleaning up our space trash, right? Which this is the first part of, is dealing with our booster trash. Then we've got the center core that has to be managed in a similar fashion. You don't seem to be blowing up. Now this is the glitch that I was talking about. Alright?
What was a glitch?
The glitch is that when you ask it what altitude and your
do
velocities are, right? So if I go into the command chip for the booster, deal with its program, velocity vertical is relative to the command pod. Apparently the command chip doesn't have its own telemetry. So we know when the altitude is above 1,000 feet AGL, right?
Right.
But what we don't know is when our velocity changes after we've detached. Because between these 2 points, right, our velocity detaches, or rather the booster detaches, and this velocity measurement is no longer red, apparently. So instead of this wait until, we need a better one. And the better one is to wait until the interstage is blown up, right? Meaning we wait until we're above 1,000 meters to be armed. Then when the interstage, the booster connector, if that has become activated, then we wait our little bit of time and then we explode. So that means that we probably have to name our interstages here, these guys. So we basically wait until we know these guys have blown up, right? So that's going to be the right booster interstage, Arbus. And this guy is going to be left booster interstage, Elvis. Right? Now, we know the goal of our staging is that both of these guys are activated at the same time, right? So we really only need to check the status of one of them. But knowing how this behaves, we might have to check the status of both. I'm not sure yet. Let's go back to our booster chip program. And we are going to wait until a given part, the part ID of booster interstage. Oh, I don't want it to be less than. I need a greater than, and the part ID greater than 0. This whole mess can go away. This little guy can go away. Oh, didn't quite get him to. Interesting. What does that do? Anyway. Alright, so now we wait until the right booster interstage has been activated, which means it's gone from 0 to 1. And I believe we can interpret this because the right booster, the status of all of the parts is known by all of the parts, I believe. So we're just going to do this based on the old timer delay. We're going to wait, so we get above 1,000 feet, wait until our booster interstage is activated, wait 1 second, and then blow everything up. But since we want to make sure that our logic is working and there's not something else failing in this, we're going to start adding some more comments. Because without the comments, we really don't know what's happening, right? So right up here, we've got booster self-destruct armed. Right. And we've got our wait until the boosters are activated. And then here we go for the booster boom. And then this way we'll see these messages and we'll know whether or not it actually got through the part of the code, whether or not this function worked the way we thought it would, which it should, but there may not be much of anything to explode when your fuel tank is empty. So, because we're waiting until the fuel tank is empty, right? Alright, so that's essentially our booster self-destruct mechanism.
Alright.
Save to craft, let's take off. Take off, eh?
It just goes pew.
So, with luck, our boosters will just go off on their own. I suppose we can do 2 times speed and get to this a little quicker.
Is it gonna go past it? That's the problem.
No, so at 2 times speed, at just this, all of the physics and everything happens appropriately. It's when you go faster than that. Oh, booster armed. Saw that very quickly there. Well, I guess our messages are gonna go by too quickly. Alright. More pitch, more speed. So our program's running, we got a booster armed message. We could also, apparently, we can send these to a log and then see it in a little log window. Which is helpful because you see the messages that have already gone by, whether they've already overwritten themselves here. We got like a 1-line message system here. Particularly helpful for long debugging. Hence the log. Go. 3, 2, 1. Yay! Booster boom! Alright, now let's just do the same thing for the core. So just that whenever the core detaches, it destroys itself on the way down. What oi?
You're gonna just redo stuff over and over?
No, that's what save and such is for. So, one of the things I found is... oh, I thought I found it. Oh, whatever. Let's just add the next widget. So we need to add ourselves another command chip. So we'll add the command chip to the center core there. Alright.
Huh?
Where is he? This one. Another reason to rename him. So this is the core CPU. Right?
Alright.
So we go back to the booster CPU. And we edit the program. Oops. Meant to go to booster CPU properties and edit program of just that CPU. And this is where it comes in helpful. You can say save program. We'll save it as Booster Boom. Then we go to our core CPU. Tinker panel. Add a flight program there. And load up Booster Boom. So, pretty much it's the exact same thing, except for the terms change, right? So this is the core self-destruct.
Right.
And then just so that we see these messages separately, let's make this 1,230 feet. Plus, the core is not supposed to detach until much later. And so the interstage that we're interested in here is called Capsule IS, if I remember correctly. Right? Core boom. And one thing that can add a little interest to this, just so we don't see the same thing over and over again. I can find the right function here. Where'd you go? Here you go, random. Whoops. Whoops. Come on now. Sometimes it gets confused between panning and selecting the object. There we go. Maybe we don't go. Come on now. Well, first off, this random was supposed to be here. And we'll wait from a random 1 to 3 seconds. That'll give it a little bit of difference. And this can go away. And now, are you behaving? No?
Hi, everyone.
What is wrong? It got confused. Let's see if it goes away when we save and come back.
Or boom.
Core boom won't go away. Whatever. Hopefully we'll get this up online and we'll just report this as a sort of strange bug-like thing. I don't know how to describe it though, but... So I accidentally... So just to document the bug, I accidentally dropped a random into a display that already had core boom in it. It then took out what was in the display, stuck it over here, and then since I've gotten rid of that, the random, but this core boom should either be something I can attach to and throw away, or put back. But that's not normally what happens to text. When you replace text like this with some other thing, it usually just disappears. So hopefully that won't mess with the program too much.
Hopefully.
Hopefully. And we only have one thing to explode. It's the core itself, right? Let's double check our part names here. First off, that's got to be named core. And did we call this? That's a fuel tank. The interstage. Ah, so it's not the capsule interstage, which is up here, that we want to go off of. It's this one. So we'll call this the core. IS. And let us not forget to go back to our core CPU and make that this core interstage. Alright, so a quick review. Altitude 1230. The core self-destruct is armed. Wait until the part ID of the core interstage has been activated. Wait a random 1 to 3 seconds, display core boom, and explode the core. So now we have something for both the core and the boosters. So now we get a little bit longer flight before it all goes kablowy.
Alright, well, let's see.
The problem, of course, is that one of the things that's the issue is our core program doesn't take into account any kind of strange upset. So luckily there's a way to manage that in the software itself with an event called onPartExploded. So if a part explodes, do this other program, which is what we'll get to next, now that we've figured out how to oh, you know, we still have that upper stage, but we'll save that for later. We'll get to what happens when things go boom. Right now we're just dealing with getting rid of our own space trash.
Killing things back on whatever.
Well, this is actually Earth still.
Oh, is it?
But it doesn't look like a very, populated area of Earth right there. And if we manage to get far enough out, our boosters will be over the ocean. Which is why we generally launch closer to the ocean. While this seems to be Earth, I think it's only Earth in, size. In other words, the texture isn't Earth. It doesn't look like. And if it is, I don't know where this launch pad is.
It looks like tundra.
Yeah, I don't know where this... there they go!
Oh.
And they were so small boom because there was no fuel left in them, right? Wasn't much of a boom. We probably want to give them a little bit more time, though, so they're a little bit further away. We don't necessarily want it to all go boom quite so soon. No soon boom. We don't need the flight.
Is that right? Well, it's going up at least.
Yeah, I mean, it's still trying to complete the same program. Which I think at this point, this stage would be... It's going to go until 20% of the core has burned out. And then it's going to wait for apoapsis, but it's still very deep in the atmosphere. It's only about halfway up through the atmosphere, so it's going to get slowed down.
So how do you get a bigger rocket?
Well, you stretch the control points to build a bigger rocket.
You what?
So every time you click on a part in the building, it puts out the little triangles.
Yeah.
You can literally just stretch them to make everything bigger.
Oh,
So
that don't look good.
Well, he was done with the core. I can barely hear it, but it's actually...
I don't care.
You can hear the burning up of the heat. That sound is supposed to be overheating. Like, what's the temperature right here? We're like 350 degrees.
350?
Like 3 times boiling
C.
water. 600 degrees Celsius. Or 600 degrees Fahrenheit. Something along those lines. Nope, here we begin our hopeless orbital insertion burn. Because we're too close to the planet. But we're going to drop the core, and it should destroy itself on the way down. Let's see. Whoops. Eek. That nearly was...
Oh!
That was nearly horrible. Clearly we need to jettison and have more time after we jettison. Maybe not random 1 to 3 second, more like random 5 to 7 seconds. Give it some time to fall. So now if we just continue it fast forward through this whole flight, what you'll see is the software doesn't know how to deal with the fact that we're not going up. Right? The software said go prograde and go into an orbital insertion burn. And if you were in orbit or near orbit, that would be the right thing to do. But right now, you're nowhere near orbit, so staying prograde means you're actually firing as you fire down towards the Earth, which is probably a bad idea. Especially when it comes to... well, you got... maybe it'll survive. Because the existing program will... well, it should have ditched that stage. I don't think she's gonna go well, Captain.
I don't think that's going well.
But at least it'll plunge into the water. Whee! At 1,500 feet, we should get a parachute.
That's pretty cool that you can see the sun. Silver. Platinum.
Whee! Come on, 1,500 meters, we get a parachute, right? It's not gonna help much, I don't think.
Oh,
parachute deployed? Really? Nope, that wasn't a parachute deployed.
Parachute deployed? Oh.
It's just sitting right there next to it.
Hey!
Whoa! So I'm on the ground, so it's a Wile E. Coyote moment. Poof, there's my parachute.
You might drag you down.
Couple of problems with all this, right?
Just a couple.
Just a couple. So one, we need a way to determine when something went sideways. Well, first off, let's adjust our times for our booster real quick. Both our booster, CPU. Let's make this more like wait 5 seconds. And on our core CPU, let's make this more like 5 to 7 seconds. So that they have time to get far away before we do anything. Stupid core boom. And then, so far, we're actually not dealing with the abnormal situation. So we need a way to signal the abort, right? And I kind of like making it a dramatic abort. So, what we're going to do is we're going to add a part that is an interstage, right? And we're just going to stick it right there on the core. And we'll give it a name called Bad Part. It'll have a lot of detachment force. And it will be located deep inside the booster core. Alright, I think you know where we're going with this. Whoops. So just the properties of booster core, we need to put them in an activation group. We're going to put it in activation group 2. Right?
Okay.
And so that'll cause it to fire like a booster interstage. And probably blow up the tank. Probably. We'll see. If that's all we need to do to make it go boom.
This is what you'd love to do, right?
Well, we're putting in a failure mode so that we can test whether, so we have we have to have a part explode for us to detect that a part has exploded. So we could probably do it by messaging, but what's the fun in that?
Do that all day, every day.
Yeah, I know. So we're going to take off, and then we're going to fire that interstage inside the booster core, at which point things will go nasty. taking off. I'm going to at least give it until it says that the boosters, or the core is armed at 1,230 meters. How convenient for the accident to wait until we're at decent altitude. Well, that was a non-melodramatic. That did not go boom the way I expected it to.
Not at all.
Alright. So instead of that, we're going to give it a program. So luckily you can put a flight program on many of the different parts in this system. So Mr. Bad Part can have his own program.
Mr. Bad Part.
Yeah. And so Mr. Bad Part is going to wait until he is activated. Let's see. He's going to wait until his activation is greater than 0. And it's part. Name of part.
Sorry.
Bad part activated greater than 0. So we're going to wait until that happens. Right? And then we're going to...
Activated.
Bad part activated. Da, da, da.
Sounds like you're setting yourself up for failure here.
Well,
Am I
exactly.
correct?
This is abort, abort, abort. This is all about how you deal with a failure. So we're setting up a failure. One that we can control. For now. So now we're waiting for the bad part to be activated. And when that happens, we are going to set part ID of bad part to exploded. So now we're actually going to blow it up once it's activated, which I think is allowable. I suppose we'll see. Now it'd be convenient for us. It would be convenient for us if it waited until we got to altitude, right? But you never know when things will happen. And nothing happens. Well, we'll save it. We'll just blow up the engine. Why not? So again, we lose one booster. Note this booster is not doing what it should be doing. Right? The booster should take care of itself. Let's go make sure the booster can take care of itself. Which is actually surprisingly easy. Now that we have the basic of it. So where we want boosters, that's what we're at. So booster, CPU, his program. We have this convenient event called on part exploded, right? So what do we do when a part has exploded? So some part on the system has exploded. It doesn't seem to tell you which one, right? I think you can use this to print out what part exploded, right? So we can say, oh, not to wait until. Display part exploded. So we'll display what part exploded, right? And then we don't really care if the booster's been on, we don't care if we're above 1,000 feet. Some part exploded. Well, I guess we do care if we're above 1,000 feet, right? Because we don't want to explode near the ground.
Right.
Or at least that was the general idea. So we could just sort of block and copy the whole thing over. But we'll start piece by piece here. So we want to make sure we're above the AGL the display is kind of irrelevant. And we're not waiting for this to be activated, but should we activate it anyway? And what I mean is, what if a part explodes and we're still connected to the core? Shouldn't we activate the interstage and get disconnected from the core? And we'll see. So some part exploded. We display what part exploded. I guess this is kind of, can't really wait until we're above 1,000 feet. But we can say if we're above 1,000 feet. Right? So we'll say if altitude is above 1,000 feet. Then we basically want to do the same thing we do here, which is display boom and set the parts to boom boom, right? So rather than duplicating all this, let's just make those 3 lines a separate custom instruction. And like I said, this would be go boom. No parameters. So there's go boom. It consists of that. Right? Let's see. And then on part exploded is that. And then after 5 seconds we go boom. And if our altitude's above 1,000 feet when a part is exploded, we go boom. See how that works?
Alright.
So the definition of what it takes to go boom is the same no matter what.
Alright.
So the thing about the interstages, right? Well, the question is, shouldn't we set the booster interstage? We don't need to explode it, but we can activate it. So that'll throw off the right booster. But since this program is the same on both boosters, we'll do that for both the right and the left. Basically, if something goes boom, make sure our interstages are disconnected, and then blow ourselves up. Now we might want to give that a little bit of time in between those 2 steps, so that again there's separation. Maybe only like 3 seconds though. So the same thing happens, whether it's due to a part exploded, or we have just fallen away. Right? So if this part is already activated, then this won't make any difference. Setting the right booster interstage activated to 1 doesn't change it if it's already 1. Right? So it's kind of harmless to do these steps, is my point. If they've already happened, it doesn't matter if they've already happened. But if they haven't already happened, we want them to happen. So this isn't actually booster boom. That's booster boom, and this is booster disconnect. So a little bit more complicated, but not too bad, right? So this will handle our boosters once, like the core goes kablammy. And I think if we wait just a little bit longer before we blow things up, both rockets will fly off and do the spirals. It looks pretty cool.
Right.
But we gotta wait till the core is a little bit lower on fuel when that happens. Looks like. Throttle up, nav going for launch.
It just really takes off, doesn't it? It gives us no time.
It's only like a 6-second countdown.
It doesn't seem like a 6-second.
Alright, the booster and core are both armed.
I see that.
I'll zoom out for the view as we destroy the engine. Hey, look at the hearts. Booster boom!
Oh, hey, that was
Hey,
cool.
we've cleaned up. And the core ignite. That's in the core jettison.
Or jettison.
And where'd the core go?
Where is it?
Did the core boom itself?
No.
I don't know what happened to the core. We missed it. We were too busy looking at the spirals.
It looked like a hot. liked it.
So now our main capsule has to protect itself, right? In the case of something exploding. So if something explodes, we want it to stop doing the program it's currently doing and do something else, right? We want it to stop trying to get into orbit, which is what it's doing right now. It's still trying to get into orbit all desperate-like.
Okay.
And instead, we want it to, throw off this inner stage so that it's just this core, fire this engine so that it can escape away from the rest of what has exploded, pitch yourself mostly northward, upward, so that you get enough height, as much height as possible. Then disconnect this stage, pop your parachute at the appropriate time, right? So we want to be able to recover the capsule automatically in the case of an engine failure like this. Is all this whole day is amounting to. So we're going to go and deal with this particular upset event called Part Exploded in the main program. We actually get into a little bit of an interesting aspect of multi-threaded programming in doing this. So you note, everything that has an on start is a separate thread of execution, so these two are running separately. So, same thing, I'm trying to get into orbit over here through all of these functions, and the staging events are happening automatically for me whenever I run out of fuel in each stage. Right? Now, they're not very smart about it because they're just using activate stage. Right? In fact, that's the parachute problem. Let's go take a quick, well, first off, let's take a look at the parachute and see what it's called. It's called parachute. How convenient. So the flight program of the parachute just uses activate stage. Well, last time, that was the final stage, interstage. It wasn't the parachute. So we don't want to activate stage, we want to activate the parachute. Specifically. Right? So we will go into... where is it? Set part activated. And actually, since the parachute is part of an activation group, it's interesting. Does it have an activation group by name?
Do you see one? No.
Like this has part or part ID of. Interesting. It doesn't have an activation group ID of. Well, we'll just go with set part activated instead of the activating of the group. And it is... I'll eventually remember where all this stuff is located, but right now I keep going back and forth. Part ID of part name. Parachute. Activated to 1. So that very specifically activates the parachute, not just generically the next stage. Right?
Yeah.
So that was the problem with the parachute program earlier. And then the issue with the main... Well, still looking at the parachute. The issue with the main program was we're still trying to do all of this functionality. Basically this thread, we're still trying to do all of these things when some part has exploded and we need to do something else. So first off, we need to identify when a part has exploded and stop trying to do all this other stuff. Right? Which actually there doesn't seem to be a way to tell a thread to stop executing. But there is a way to put a thread into an infinite loop and therefore stop doing anything new. But first we need a way to signal between the two threads, and in a typical operating system this would be done with something like a semaphore, which is a special operating system flag that says, give me the handle to that flag, and while I have it, anybody else has to wait on it. And when I'm done, I release it, and then the other thread says, okay, I was waiting on it, so now I have the flag. And that keeps you from reading and writing to the same block of memory, is primarily what it's used for. But it can also be used to signal when things need to go differently or do something differently.
Right.
So in this case, all the variables are what would be referred to as global variables in C. They're available no matter what function you're in, as long as it's the same page here. So anywhere inside the command pod's program, you can get to any of these variable names. Whereas in the C language, you could have variables that are only available within the dorbit function, variables that are only available within this file, or variables that are available throughout the entire program. And most of it is actual just syntactical things. Apparently they don't need that kind of complexity here, so we'll just create a variable called abort. Right?
Okay.
And we will set that abort variable when the program starts to... Come on now. We will set it to false. Sometimes the click and drag gets out of sync, and my mouse cursor is way over on one side.
Nice.
Anyway, we'll start off with the setting it to false, and then end with the event of on part exploded. We will set variable abort to true, and that seems pretty straightforward, I would imagine. But now what do we do with this true abort variable, right? So we've set the variable to true, but we're still not paying any attention to it anywhere else. So actually what I want is a little function I can drop in at several different places in these bigger functions that will check this abort flag. So in this world, that's a custom instruction. And that instruction is check abort. And we don't need any parameters. Where'd it put it? Okay, way over here. Alright. So now to check abort, we want to say if this abort flag is true, we want to do something special. Right? We're going to do something different. So if abort flag equals true, then what do we want to do? So normally I'd say stop the thread, return in thread, something like that. But we don't seem to have that here, so hey there, Mom 999. How's it going?
Hi there.
So, but what we can do is we can say while something is true, do whatever's in this block, right? So what happens when you say while true is true? You never leave, right? You're never going to leave this while loop because true is always true. So while true is true, and I'm not sure if this would throw it, so like an optimizing compiler would say, while true is true, do nothing. Well, that's stupid, and it would throw it away. So I don't think it will, but just in case, we're going to throw in a comment in the middle of it. Stay here. So that's basically what check abort does. If the abort flag is true, while true is true, stay here forever. And what that allows us to do is take our custom instruction of check abort, right? And basically say, after the countdown, check abort, in case something blew up after countdown, after ascent, after the orbital insertion burn, after the circulize burn. And of course, there's no point in checking abort after deorbit. But that way we can throw that check in a number of places. In fact, since the ascent is where we're currently testing our failures, right?
Alright.
We can throw in a check abort pretty much anytime we're done waiting for an event. So we wait until the altitude's above 1,000. We check whether we should continue or not. Right? We do various stuff. Then we're waiting until, because it's what we do after these wait untils. Because we can't do anything inside this wait until in this
Do you
thread.
have a Discord server?
No, I've seen and heard people talk about them for a while. I haven't really looked into them, but it's basically another chat room kind of a scheme, as far as I can tell. Chat board, message board.
Is it like this? Or it's another thing?
I think it's text-based. I don't know. I tell you the truth, I haven't really looked into it. But after our wait untils, we'll throw in some more check aborts. So, since that's when we're waiting, most of the time that's what's going on, is we're waiting for some stage to happen. Let's see. Wait until there.
Check abort. It's not how you spell check.
It is in software. I hate when I accidentally rearrange the code. So let's try a couple of undos just to make sure. Okay.
Don't do that.
There's a couple of undos. When in doubt, undo. Another wait until. Or maybe that's just always been behind there. Just sitting around waiting to be thrown away. And then there's another wait until. So on any given one of these wait untils, right as we come out of it, we check whether we should abort. And we do that for the ascent stage in high detail. And we do that for the other stages in sort of low detail here. But now, anytime we've got a part exploded, we can abort that program, right? So, let's let everybody know that we're aborting the program, right? On part exploded. Hence the title of the program.
Abort, abort, abort.
Abort, abort, abort. So now, abort is true. Now, what do we actually want to do? Since we're the capsule, we want to get the hell out of Dodge, right? So we want to throw off everything below us, fire our last engine, and point northward. So to throw everything off below us, well, that would be the Capsule Interstage, right? We activate that. Right? So let's see. Where to go? Wait until set activation groups. Oh well, I'll just go get it from the library again.
Oh yeah, no, we're not doing any Discord server.
Have you looked at it? I don't know.
Yeah, sorry.
Seems like a lot more work to me.
Zero interest in that.
Alright. So let's see. Yeah, I mean, we've got like a bajillion different ways of chatting, right? There's chatting here, there's chatting on YouTube. You know, there's a heck of a different ways of doing it, so. I'm not sure what Discord brought that was better than anybody else, but. Anyways, we need to abort. We're setting the abort variable to true. Which should cut off the rest of our programs now, right? We'll end up stuck in these loops. So the next thing we want to do is we want to activate the core or the Capsule Interstage, right? So again with the part ID of see, come on you. My typingness is not working today. I think it was called Capsule. S-U-L-A-I-S. I believe it was. The Capsule Interstage. Right? So that's the Capsule Interstage. Then what else do we want to do? We want to do some things that we would normally do during ascent. Right? like we want to set the throttle to 1. We don't care about being a slow pitch over. We really just want to set craft pitch to a high pitch so that we're getting up and away from the exploded parts. Right? So we're going to set throttle to 1. We're going to set the craft pitch to... Actually, don't want to be completely straight up because then your core could run into you and stuff like that. We kind of want to be at an angle so that everything else drops off away from us. So we'll maybe make it 80 degrees or so. And then we also want to activate the capsule engine.
I wish I could actually use simple rockets too. It's full of potential, but my tablet isn't up to spec.
Yeah, and on the tablets, I tried using this on the tablet. It really helps to have a keyboard still for these kinds of things. For all these named things. Which again is why it would be very abbreviated. Right? So we've activated the Capsule Interstage, and then let's double check. There's the capsule. This is called Capsule Interstage, yes. Oh, we don't want to do that one. Dang it. Because we would lose our rocket. We want to do the core interstage. And then our rocket, which is a upper stage engine. Alright. Upper stage engine and the core IS are the two keywords we need to remember. Long enough to get back here. So the core interstage, we throttle to 1, we set our pitch to 80, and then just in case the engine has not been activated yet, we want to activate it. And so it shouldn't have been staged yet anyway. So this says abort, fire the engine, make sure the engine is staged to fire. I guess we could, this probably makes a little bit more sense back up here.
Couldn't you ride the shockwave from the exploding part?
Apparently not so much.
No. Not from what I've seen.
Maybe not in this physics. Maybe in some more real physics. Certainly the explosions look a lot smaller. Yeah. Then again, this is a smaller rocket.
To gain more speed, yeah. It's a small rocket.
True. And plus this is a vacuum engine, and we're going to still be in the atmosphere when things go wrong. So let's see. Got it all over, and of course we don't want to burn forever. We don't want to burn up all our fuel, right? We really just want to burn for like 10 seconds to get out of the way, right? Because we got all the fuel in the second stage. We don't want to take forever on that. So we'll burn for 10 seconds. And then we're going to set our throttle to 0. And now we want to wait until we reach the top of the arc and we're falling again. Now this is where I had originally experimented with the vertical speed with a wait until your vertical velocity is less than 0. Alright. So we're waiting, so we fire our engines, we go up, we wait until we come to the top, and we start to fall. And as soon as we start to fall, maybe we give it, I don't know, 2 meters per second. And I guess I should say negative 2 meters per second. It's because vertical velocity is plus or minus, whether you're going towards the planet or away. So we're going to wait until everything's falling nicely. And we are going to activate. Here's where we activate the Capsule Interstage. And let's put in a little bit more displays so we know what's going on, right? So throttle up, pitch, and firing the rockets. That's all. Well, let's wait for the 10 seconds. If there's not enough time in between here, we won't see the messages go by. So, I hate when I accidentally duplicate a button like that. So now, we'll consider that escape success. When we coasted up, or we've just stopped the engines and we're coasting to the top of an apoapsis. Wait until we're going into some negative speed so that we can then ditch the lower engine, and hopefully our altitude is such that our parachute will go off for us, right? Because our parachute will activate at 5,000 meters and will then deploy at 1,500 if it's above 5,000, and then deploy under 1,500. So that looks like a decent failure mode, right?
Yeah.
And hence the name of the show, Abort, Abort, Abort. So here we go.
All right.
Let's go see if our craft can save itself when we blow up the engine. Now, the parachute has its own program, so as long as we're above 5,000 feet when everything happens, the parachute should deploy itself. So we're going to let her get up to some decent altitude. There you go. You ready for the destruction of the rocket?
Whether I am or not,
Booster,
it's gonna happen.
pitch, core, self-destruct armed. Oh! Oh, the boosters saved themselves. Booster boom. Ah, my rocket got exploded with it.
Did it?
Oh no. Well, the program still is operational. Escape success. Even though we didn't have a rocket to fire.
How funny.
But look, our altitude, 490,000. Oh no.
And it's going down.
Our parachute has not been activated because we didn't crack 5,000 meters. Oh no. Will it deploy? Will it deploy anyway?
No. This time you're going to smack and blow up.
Oh, let's see it up close. Here we go. If it deploys, it'll be 1,500 meters. Nope. Bye-bye.
Oh,
right by the launch pad even.
Bye-bye.
Notice it said abort, abort, abort again.
Oh,
you know why it did that? Because other parts exploded after the fact.
Oh.
So we don't really need to repeat our program if we've already had one flight abort, right? If we've already had one thing go off, we don't need to abort again. Right? So in our core program, over here on our part exploded, we really only want to do everything under part exploded if abort is currently false. Right? So, if abort let's get the equal sign. Mr. Equal sign. If abort equals, come on, scroll down. If abort equals false, then we do all this stuff. But of course we set abort to true here.
On most space shuttles there would be a manual override for parachutes.
Yeah, most likely. And if I understood the messaging system here and I could send like a remote abort command, that'd be nice. But what we're going to do here is we're going to kind of override the, like you said, a parachute override. Which is going to consist of an if statement right under here, which is if the... What do we want? We want... if the altitude... AGL, right? I always forget the comparisons. You need the comparisons first. If our altitude AGL, when all this went boom, was less than 5,000, right? Then our parachute isn't going to deploy on its own.
Right.
Right? So what we can do is then basically duplicate what it does in there. Wait until our altitude AGL is less than 1,500. And then set part ID of parachute to activate it. So now we're getting into some like staged if statements and a little bit more complex logic, right? We're not just doing straight line code, take off, do this, do that, do the other thing. It's, you know, parts exploded and we haven't handled a part exploding before, which is essentially what that statement is. This is why I say the comments, this is actually a week or two of fiddling. But that's why I say the comments are meant to be why you're doing something. Anyone who can read the code says, well, what does this line do? Well, it says, if the abort is false, then do what's in the box. And if abort isn't equal to false, then don't do what's in the box. Well, that's what it's doing, certainly, but that doesn't tell you why you're doing it.
Everyone new coming in.
That I always harp on, I guess. I'm beginning to harp on why for comments. So, since I can't put the comment like right next to it, I'm putting the comments underneath it. So, because going through this thread a second time may interfere with the operation of the thread, the first operation of the thread. So we don't want to, we want to prevent this fancy word called recursion, which is to say that something inside your function called you to call the function, and in fancy code that is all cute and such in computer science degrees, it's very convenient. You can recurse a function, cause it to go down a list, find the last item on a list, and then come back up. It's all nice and neat. It's very undeterministic. It can blow out all your stack space when you least expect it. So recursion is actually a bad thing in safety critical systems. It's great and everything and makes for slick code in desktop examples and so forth, but not good for embedded. So we want to prevent recursion, which is what that if statement is actually doing. That's why we're doing the if statement. So I'll quit harping on that for that.
Thanks.
So moving on. So now if our part has exploded and we haven't aborted, then we go through the abort sequence, we try and escape, and this is assuming, of course, that we haven't blown away our upper stage engine. But even if we have blown away our upper stage engine, we're pretty good, except, of course, if we didn't break 5,000 meters, in which case we have to activate our parachute on our own. Sound good? Sound good. Yes, let's fly.
Hi, everybody new coming in.
Time to fly. This time we'll blow it up a little later, so maybe we don't lose our engine. I also think when you tell it that a part is exploded, it says that 0 means it becomes deactivated, but doesn't like really explode. And 1 is a total explosion, which usually takes out the thing it's connected to. So apparently, though, I tried making it like 0.1, and it didn't make for a small explosion. It just didn't really work the way I expected. But all right, we've got our core self-destruct is armed. Let's wait until our fuel's cut down some so that we don't blow up our engine here. And we'll stay nearby so we can see what happens in detail, rather than zooming out to watch all the booster spirals. Alright, we got about 30-some% let's blow up the main engine. Oh, we blew away everything again.
Oh.
Dang it. Nose cone? What was nose cone? I don't remember saying nose cone anymore. Oh, nose cone was what exploded. Or at least it was the last thing that exploded. A bunch of other stuff exploded too. Well, at least we made it above our 5,000 foot requisite altitude. So, let's see. Our velocity is increasing nicely.
It might not be a parachute.
Yeah, oh yeah, the parachute's there. Parachute's okay. So now we just wait. And fast forward. So at 1,500 meters, we maybe get a parachute. Maybe we don't. Whee! We're not all that far from the Space Center.
Right there.
Come on, 1,500. Whee! Alright, now we're doing good. So, now we're dealing with some abnormal situations in a decent fashion. We just need to make our abnormal situations a little less problematic. So they're not quite so destructive. And I know a way of doing that. Apparently the boosters are a whole lot more tough than the, a whole lot tougher, I guess I should say. Bloop! Well, I lost my parachute, but we're okay.
Next is a man test.
A man to test?
No.
Nah, well, I guess so. Well, they do have an astronaut-like thing that's supposed to be an astronaut, I guess. But he doesn't seem to have any name or anything like that, you know. There's no characters.
Still just figuring it out.
Yeah, plus our parachute's too small. We're still running into the ground running too hard into the ground. So let's find bad part here and move him around a little. So what I've noticed is if you put the bad part on a booster, it's not nearly as bad a part, but it still explodes. And we'll actually blow it up instead of the engine. So I think it'll even respond if the booster's already disconnected and then later explodes. But you have to be quick about it. So just before we get to booster separation, we'll destroy bad part. And then what now?
I don't know what took off, what just blew up.
Oh. Apparently it was automatically staged down at the bottom. So our part already blew up, I think.
Yes.
So that's rather problematic. Again, with activate stage instead of saying activate engines. Let's see, looks like we can still blow it up. Will it matter? I don't know. Yep, there's our escape. Booster disconnect. Cord took itself out. And we're on our escape. Yay! Are we gonna crack 5,000? Yay, we cracked 5,000! Oh, and there we go. We jettisoned the core as we began to fall, just as programmed. And then it's going to explode, which would have caused another part exploded message. And there's our convenient parachute. Well, ain't that nice? Now we got to worry about things happening much closer to the surface. And you know what that means. a mess on the ground. So interesting that that's what goes boom on the stage, right? But let's go ahead and fire off, shall we?
Sure, why not?
You ready? Here goes a low altitude self-destruct test.
I mean, I had an astronaut do a free fall from space.
Whee!
Because somebody else always wanted us to do man stuff.
Blam! Look, that engine barely has enough thrust to hold itself up. Oh! Oh no! Oh no! Well, that's a mess. Hey, but we're safe on the ground. I don't think that would have been real. Let's try it when we take out the mage engine. Of course, if we do that, we may not have anything left. We'll cancel. So that's, by and large, what I was looking to get to.
Well, that's cool.
So now it's all just a matter of testing at different altitudes in different situations. And I gotta figure out how I can blow up one part without necessarily blowing up everything else. It's convenient that it can be activated and yet I can still blow it up later. To provide a signal without causing any damage to any other parts. I can blow up this theoretical part here. So here we go. We get right to half of the boosters. Oh! I lost my part. Oh well, I guess I'm killing the engine again. Alright, we'll wait until there's very little fuel left. Actually, I guess that center core is completely full of fuel. It hasn't even ignited the engine yet. So, booster disconnect, nose cone which has exploded, are pitched up. We should probably get rid of which part exploded, considering that a lot of parts explode. These tests. Our escape success, now we're going to wait until our speed becomes negative. And we do that so that we're not sitting on top of the rocket capsule. Disconnected, but still sitting on top of it. So I want to wait until we get to what is essentially our apoapsis. Actually our apoapsis, right? But here's our vertical speed slowing down. And -2 negative, we ditch it. I guess that core should destroy itself on falling too, right? The upper stage should clean itself up.
I guess.
We'll put that in for next time. Whoa. Do a little fast forwarding so we can get to the ground. Look at that. It's a weird flight path for that piece of junk. Anyway. 15, 14, coming up on landing. So now that we've got our abort system in place, now I feel safer about putting theoretical humans on board. But there's also a test dummy, so we're going to put the test dummy on board first. Hopefully the test dummy actually collects data. It says like, broken bone, all that kind of, that'd be fun. It's like, you landed, but he broke his bone. Yay, parachute automatically deployed. It's so easy to make me happy. No, it doesn't. Which doesn't?
So what doesn't?
I know. So many things we've said in the last 5 minutes. This is still a little bit fast. 19 meters a second. Bloop. What's interesting is you can repack the parachute. I always thought that was an interesting little feature. Whoop. 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 Whoop.
You're so cute. The things that you think are funny.
Such a convenient little repack of a parachute. Oh, the test dummy doesn't do it. Ah, dang it.
CLO. I don't know what CLO is.
It would be helpful if the test dummy would report its failures. What good is a test dummy that doesn't report its failures? Well, what happens if we fail at Launchpad? Not much. Bad part exploded, and our engine is firing right through the middle of the other engines. Or something. Let's see what happens next. Whee!
Don't question it.
I love how it just hovers there in space.
Alright, I'm out.
Alright. Well, that's about it for now.
Thank you very much for...
We'll try one more low-end failure here just for giggles.
Oh, you do that. I don't like a night of failures.
Well, it wasn't a failure. Every time the parachute it landed with the parachute was a success. Like 3. Well, no, it was all about making sure that we won't have failures in the future, and that's very critical. I'm out, she says. And we're launching. And really early on, we explode. Ah! And we drop all that center stage and the booster cores and everything to the Earth to blow up our launch pad.
You're funny.
Yay!
You're a fun guy.
Fun guy. Don't call me fun guy.
You are. You're a fun guy.
Woo! Another little blow up. Alright. Well, I think we're gonna call it there.
You can stay.
What? I can stay and blow it up some more? Sure, alright. Let's blow it up one more time. Just one more time! That's the problem with this game. Just one more time I'll launch and maybe try it. It's kind of like the Mario games where you just started over when you got to... if you failed. Yeah, Sonic. That was less fun than I imagined it would be. I wonder if I blow up a booster engine, what happens? We're going to take out a booster engine once they're down to about 50%. See if we still manage to successfully escape. Let's actually do it at a low altitude. Like there. Oh, booster! Oh, we got plenty of altitude. Or do we have plenty of altitude? Not quite. Let's see if our main program saves us. Ditch that stage. And fast forward to the parachute deploy. Because as long as the parachute deploys, I trust that it'll land safely. Alright. Cool beans. Well, I hope everybody had fun. It was,
You had fun, that's all that matters.
well, I had fun, that's all that matters, she says. Well, this is partly true. I'm glad that you have fun, mostly, sort of, kinda. Ish. All right. Well, we'll hope to see everybody next time.